Good morning, learners. We have started with Unit 4, Lasers and Optical Fibers. In the last session, we have looked at the characteristics of lasers. Now, the second lecture is on phenomena of absorption and emission. So, we have basically three phenomena: absorption, spontaneous emission, and stimulated emission. So, first look for absorption. Suppose that you are having two energy levels, E1 ground state, E2 excited state. The atom resides in the ground state for infinite amount of time. But when the atom is given with an additional energy, it immediately excites. So here the atom is residing in the ground state. For this ground state atom, we are applying certain amount of energy because of which the atom is excited. So what will happen for the atom? It reaches to the higher state, that is E2, releasing an amount of energy delta E, nothing but E2 minus E1 equal to h mu. So in the absorption process, the atom is in the ground state. When we apply certain amount of energy, this atom is excited and reaches to level E2, giving an amount of energy delta E equal to h mu. This excited atom will not reside in the excited state for longer time. Once its lifetime is completed, it de-excites. So you have used absorption phenomena because of which the atom is now in E2 state. This excited atom de-excites once the lifetime is completed, releasing an amount of energy h mu. So this photon will be moving randomly. Now, this atom could be de-excited before the completion of lifetime. We are saying in spontaneous emission that the atom de-excites if its lifetime is complete. That is spontaneous. But before the completion of lifetime, if we are allowing it to receive some amount of energy, you are incidenting some amount of energy before its lifetime is complete. That is, before it gets de-excited on its own, we are giving some energy to it. Then what will happen? Because of the energy that you have given, it de-excites before completing the lifetime. Then we have here two photons to be emitted. Two photons are emitted. The emitted photon is now has the direction same as that of incident photon. So you are having here spontaneous means de-excitation happens on its own. In stimulated emission, de-excitation is due to external energy that you have given. So looking for the differences now between the spontaneous and stimulated emission. Spontaneous emission is a polychromatic radiation. You are having the photon to be moving randomly. But what is happening in stimulated emission? The photon is moving in the direction of incident photon. So it is a monochromatic radiation. Here, the de-excitation of the atom has taken place because the lifetime of the excited atom was over. But here what happened? Before the lifetime is completed, we gave some energy to it. We have infused the energy for excited atom, because of which it undergoes de-excitation. This spontaneous emission is an incoherent radiation. Stimulated is a coherent radiation. Spontaneous doesn't require any radiation to be incident, so we say it is independent of incident radiation. But stimulated requires the radiation to be given for it, so the de-excitation takes place. So we call it as depending on incident radiation. Here, a single photon is emitted. Here, two photons are emitted with energy same. This was the phenomena given by Bohr. This was postulated by Einstein. Here the rate of emission depends upon the concentration of upper level. Here the rate of emission depends upon the concentration of upper level and the energy of the incident photon. These are the differences between spontaneous and stimulated emission. But the emission can be in a system, the emission is the sum of both spontaneous and stimulated. It could be either due to spontaneous or due to stimulated. This is for today's session. Thank you.